You are welcome to this video. Today I want to share with you how you can evaluate double integrals. Double integrals. Yes. So to do this, let's look at some questions here. Yes, I'm going to solve these two questions. And I believe that after solving these two questions, you should be able to evaluate any double integral at all. Yes, so viewers, sit down quietly, pay attention as we solve these questions. Now, solution. The first one, you have been asked to evaluate this. Evaluate this. They are calling this one double integral because of the two integral signs. Is it? So this one is the same as, look on the board, integral from 1 to 2, integral from 2 to 4 of x squared y plus 2y dy dx. Now when you are giving something like this to evaluate, please start from the internal one. Look at it. So we are going to start with this one. This is the outer one, this is the inner one. So we are going to start with this. So let me draw this. Let me draw something around it so that you know that we are going to start with this one. Now, look on the board. This is the same as, so this is equal to integral from 1 to 2. So what this means is that we are going to integrate this one with respect to y. When you get the answer, you are going to evaluate, and then when you evaluate, you integrate with respect to x. So if you integrate this one with respect to y, you are going to get something like this. You are going to get x squared y squared, and this one will be y squared over 2 plus this one will be y squared over 2. So 2 cancel 2, so you are going to get y squared. Now let's put in the limits 2 to 4. And then you are saying that dx is x. Now this is equal to, if you put in 4, wherever you see y, because you integrate with respect to y, wherever you see y, you write what? 4. If you put 4 here, 4 squared is 16. Divided by 2 is 8. So this one will be integral from 1 to 2 of 8x squared plus, when you put in 4 here, you are going to have 16. I said it minus, let me do it this way so that everybody will understand. Minus, when you put in 2, when you put 2 here, 2 squared is 4, divided by 2 is 2, so this one will be 2x squared. Plus, when you put in 2, wherever you see y, you are going to have 2 squared is what? 4. So have it this way, dx. So this one is equal to integral from 1 to 2, 8x squared. Then when you open the brackets here, we will have, okay, let me do this way, 8x squared plus 16 minus 2x squared minus 4. When you open the brackets, dx. This is equal to integral from 1 to 2. 8x squared minus 2x squared is 6x squared. 16 minus 4 is 12. Dx. So this is equal to, we are going to integrate this one with respect to x. So this one will be, you see, this one will be x cubed. The x squared, you want to integrate it to be x cubed over 3. And 3 goes into 6, 2. So this one will be 2x cubed. Isn't it? Plus, this one will be 12x. When you integrate 12, you get, with respect to x, we're going to get 12x. Now let's put in the limits of integration, 1 to 2. This one will be, when you put in 2, 2 raised to the power 3 is 8 times 2 is 16 plus 2, 12 times 2 will be 24 minus, when you put in 1, I can put this in brackets, minus when you put in 1, You put in 1, this one will be 2. Then when you put in 1 here, this one will be 12. So I'm going to have this plus this is 40. This plus this is 14. So the answer is 26. So viewers have seen that it's not difficult at all. Yes, it's not difficult at all. 26. So 26 is the answer to the first one. Now let's quickly look at the second one and bring this lecture to an end. And after the second one, you should be able to evaluate any double integral at all. So we are done with the first one. Let me clean it. We are done with this one. Now let's look at the second one. Question number 2. Solution. Solution. So solution to the 2. Now we have integral from 0 to 1, integral from 1 to x, x squared plus 2y plus 2 dy dx. This is the question. Now, as we did in the first one, you have to start from this one, the inner one, isn't it? So we're going to start with this one. So let me just draw something around this so that you know that we are going to look at this one first. Now this one is the same as integral from 0 to 1 is equal to. Now we are going to integrate this one, the whole of this, with respect to y. So this one will be x squared y. When you integrate x squared with respect to y, it will be x squared y. You attach y to it. Plus, when you integrate this one will be y squared. When you integrate y with respect to y, it will be y squared over 2. So you 2 cancel this. So this y squared. Plus, integrate this one and that will be 2y. Then put in the limits 1 to what? X dx. Now, what this means is that because you integrated with respect to y, wherever you see y, you write what? X. When you finish, wherever you see y, you write 1, then you subtract. So this one is equal to integral from 0 to 1 of wherever you see y, you write x. So this one will be x cubed plus, I've seen y here, I'm writing x squared plus, I've seen y here, I'm writing as 2x. Isn't it? Minus, when you put in 1, wherever you see y, you write what? 1. So this one will be x squared, we put 1 here. This one, you are writing 1. So this one will be plus 1, you are writing 1. This one will be plus 2. Isn't it? This way. dx. Yes. Now, this is equal to integral from 0 to 1. Now, let's look at what is happening. Let's look at what is happening. If you open the brackets, you're going to have x cubed plus x squared plus 2x minus x squared plus minus 3. 1 plus 2 is 3. So when it comes out, it will be negative 3 this way, dx. And this is equal to integral from 0 to 1. This is x cubed. So let me write it. X cubed. Now x squared will cancel. Positive x squared will cancel negative x squared. Isn't it? So these two will go. So we have plus 2x minus 3 plus 2x minus 3 dx. So I'm going to integrate this one with respect to x. So if you integrate this one, x4, x to the power 4 over 4 plus this one will be x squared over 2. The 2 cancel this 2 minus 3x. And then you put in the limits of integration 0 to 1. So when you put in 1, you're going to get 1 over 4. Plus when you put in 1 here, you're going to get 1. When you put in 1, you're going to get what? 3. Minus when you put in 0. When you put in 0, you're going to get 0. So there's no need for you to work that one. So this is equal to. Now 1 is the same as 1 over 1. 3 is the same as 3 over 1. Now the LCM here is 4. 4 goes here, 1. 1 times this is 1 plus 1 goes into 4, 4 times 4, 4. And then 1 goes into 4, 4 times 3, 12. So we are going to have 1 plus 5 is, 1 plus 4 is 5 minus 12. That will be negative 7. So the answer will be negative 7 over 4. So viewers, this is the answer to the second question. So if you have really understood these two questions, how you solve these two questions, then evaluating double integrals should not be a problem at all. Yes. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr. Thank you very much, viewers.